Welcome to episode 11 of CipherVibe's end-to-end cloud security architecture course. Serverless platforms remove host administration but intensify identity, event, dependency, and data flow decisions. A small function can still become a powerful cloud control plane actor. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. Serverless functions consume machine identities, secrets, API gateways, data stores, logging, and incident response. The absence of server management does not remove the need to define permitted calls and safe failure modes. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is scope every function identity. Give every function a dedicated identity with the minimum cloud actions, resources, and conditions needed for its purpose. Do not reuse broad deployment or application roles. Review event source permissions and cross-function invocation as carefully as direct data access. The second building block is bound execution and concurrency. Set realistic execution timeouts, memory, concurrency, retry, and dead letter policies. These controls limit runaway behavior, reduce denial of service impact, and make failures observable. Make sure retries cannot repeat destructive operations without idempotency and correlation controls. The third building block is secure code and dependencies. Scan dependencies and deployment bundles, minimize libraries, keep runtime versions supported, prevent secrets from entering environment variables or logs, and retain artifact provenance. Functions may be small, but their third-party code and permissions can create an outsized attack surface. The fourth building block is protect triggers and APIs. Use API gateways and event source controls to authenticate callers, validate schema and size, rate limit abusive traffic, and prevent untrusted events from reaching privileged operations. Log request IDs and policy decisions without exposing secrets or sensitive payloads. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. A secure serverless pattern gives each function a narrow identity, validates every trigger, bounds execution and retries, uses managed secrets, and sends invocation and error evidence to the operational layer. Implement this layer in a sequence that preserves evidence and limits blast radius. First, inventory functions, triggers, identities, data stores, and external calls second. Replace shared roles with function-level least privilege third. Set timeout, concurrency, retry, and dead letter policies fourth. Scan packages and protect deployment artifacts fifth. Add API and event validation with correlation logging prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, giving every function one broad shared execution role second, allowing retries to repeat side effects third, treating function environment variables as a safe secret store fourth, accepting unvalidated events from public or cross-account sources. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, test valid and malformed event handling second, measure per function permission scope and timeout coverage third, alert on invocation anomalies, failure storms, and unexpected destinations fourth. Exercise a safe rollback and event source disablement test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, design a file processing function that may read one upload bucket and write one result bucket, but cannot administer the account. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that serverless security becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.